Okay, welcome back to another video. This video is going to be on trigonometric identities. So I'm actually using that is my term for chapters 4F, 4G, and 4H. That's going to be a lot of work. Some of these we've covered already, but I decided to make a big video where I cover all of the relationships and with lots and lots of examples. So you'll find me doing all of these at some point. And I thought it'd be useful to go through and look at all the different relationships and put them all in one place. So you can see I've actually done these ones. I've actually labeled these for which parts they are, and for the so on and so forth. And okay, so we've got angle relationships. We introduced these in methods. So sine being even, negative sine acting on negative angles has the same relationship. That's why you find the same negative. So like going from first to fourth quadrants would be the sign change, the same with second and third, and that's what you'd see here. Cosine, however, actually doesn't change. It's the value for a cosine positive angle is the same as cosine negative angle because the first and fourth quadrants actually have a positive symmetry. Yeah, and again, you get a bunch of other ones as well. So in methods, we actually kind of drew these out and looked at them. But if you remember the idea, when you're shifting angles, positive is moving anti-clockwise, negative is moving clockwise. So if you start at pi and move backwards, there's a symmetry with sine because, for example, unit circle, just a reminder, if you work out something in sine is y, so if you go that way in theta, or if you start at pi, which is 180 degrees, and go backwards, you're ending up at the same height. And that's how all of these work in different ways, though. So, and also just to note that you've got the ones that that change sine to cosine. So pi on 2 minus theta equals cosine theta. Pi on 2 minus theta and sine theta. All right. So in Pythagorean identity, we also did this one in methods. Sine squared plus cosine squared equals 1. You could use that to convert from sine to cosine. These two are derived from that. This one's quite useful in other applications. So in integration, in integral calculus, being able to integrate different functions, sometimes we need to rearrange them from one form to another. Sec squared is actually easily to integrate, so we have often convert tan into sec squared for that purpose. Now, this is just if you think about the top equation divided by cosine squared. Sine squared over cosine squared is tan squared. Cosine squared divided by itself is 1, and 1 divided by cosine squared is sec squared. All right, and the third one I don't use that much, but it's basically the first equation divided by sine. 1 plus, well, cosine squared divided by sine squared is cot squared, and then that's cosec instead of sec, cosec squared. All right, so it's the same sort of thing, but I haven't had much use of that one in stuff I've been doing. Okay, just for the reference for 4F3, factorizing using quadratic methods, we'll just come back to that. We'll use them as we come, just a reminder. So difference of two squares, and perfect square rule, and also your sum and product. So we will go through examples and show those, but that's again stuff you've done before. Okay, last few things, double angle identities. So sine 2 theta can be expressed as 2 sine theta cosine theta. Cosine 2 theta often has 3 ways to write it. You've got cosine squared minus sine squared. Using the Pythagorean identity, you can actually find 2 more by eliminating either sine or cosine. Basically, if you do that, you can either express it as 1 minus 2 sine squared theta or 2 cosine squared theta minus 1. So there are 3 variations of that one. There's also a tan double angle formula. All right. Now, I believe we covered some of these in methods as well, but just a reminder, cosine, so angle and sum difference, The plus or minus, so you can vary that. If you look on the other side of the equation and it's upside down, that means when one side is positive, the other side must be negative. So it's just, there's a way of, so we don't have to write 6 equations for cosine a plus b and a minus b. You can just kind of write them as one here. So if it's cosine a plus b, then there'll be a minus between the cosines and the sines. If it's minus here, that will be a plus. Sine is that one, and tan, be careful because you've got a plus or minus and a minus and plus. So if that's positive, that top one's positive and that one's negative. All right, so I thought I'd show all of them off first. It's probably worth your while to make yourself up a little table like this. So in one place, maybe in the back of your exercise book, just have them all there. I'm in two minds about what I'm going to be doing insofar as the next assessment, but we'll take a look at these in due course. And I might give a formula sheet, or I might suggest that you write these up in your revision notes. All right. Okay, so yeah, you're welcome to go try for yourself. You can pause the video or maybe skip around and look for things that you might be confused about already. But I'm basically just going to go through. I'm not going to go through every question. I'm going to skip around a bit, but I'm going to be quite thorough. So I'm going to start from each page, and I'm going to go through a few. Now, some things are just going to be very easy peasy, like this one, sine. Okay, sine theta plus sine theta. Well, you just got 2 sine theta. Okay, well, that's easy. You don't really need a rule for that. All right. And same about grouping up terms. You can treat like your sines and your cosines as like the same way you treat x's and x squares. So I've got 2 cosine squared theta minus 5 cosine squared theta. Oops, theta not x. Oops, you can't actually see that. Oh boy, what should I do? Make that a bit taller and make that a bit. No, let's turn you around. There we go. That's a bit better. All right, that's a bit better. So I've got a bit more space to work as well. Yep, awesome. All right, minus 3 cosine squared theta. All right, 3 tan x minus sine x on cosine x equals 2 tan x. All right, because that's going to become a tan. So 3 tan minus 1 tan is 2 tan. All right, 2 tan. So we're not even using right now any of the new formulas or anything else like that. At this stage, we're just using just simple reductions and rules that we know, tan definitions. Okay, so just be aware. All right, so tan x can be written as sine over cosine, so you can write that as 2 sine x on top over cosine x, and that all the sine x is still on the bottom. And then you can essentially just divide those out, and you just got well, either 2 over cosine x, or as we know, cosine x can be written as sec. 2 sec x that's probably what they were looking for, or 2 over cosine x if you prefer. All right, so let's try a few more. All right, simplify. Tan x cot x. I believe that's going to be a complete cancellation. Now you can either write out that sine over, maybe I will, but also remember cot x is tan x to the power of minus 1, well, basically is tan x divided by tan x, so you don't even necessarily need to go to this step. If you realize that, you can cancel them straight away. So tan x, okay, is sine over cosine, cot is cosine x over sine x, and then they're just going to cancel, so it equals 1. Easy. Cot divided by cosec. All right. So cot x divided by co. No, I'll write it that way. CSC is cosec. All right. Remember, cosec is sine, or 1 divided by sine. So I can, and if I'm dividing by that, but think about that. Okay, well, if I use my laws of indices, I could express that as tan to the power of -1 on the top, and sine to the power. Actually, no, sorry, not the power of -1. I'm getting myself confused. That's inverse functions. Be careful with that. So put a bracket and put a -1 here to not confuse it with the inverse function, because you get confused very quickly. And using the laws of indices, I can move that to the top and that to the bottom. So then it's sine x over tan x. And, well, you've got sine x divided by sine x over cosine x. And that's sine x, if I times by that, times by cosine x on sine x. Maybe it's a bit convoluted this way, but you end up with cosine x. Okay. All right. Now we're going to start using the rules. So we can see the first one here, 3 cosine x minus cosine x. All right. Now, kind of realized one thing I was actually going to do when I was planning this is I was going to take a picture of that book, or the picture of this book and that page I wrote out, and just go over them. However, I'm just going to have to keep flipping back and forth, or I'll think of something in a minute. I remember this one. Cosine is even, so thereby there is no sign change outside. You can write it back there. So when you're reducing, you need to have cosine of same angle. So you can't reduce, you can't just minus them like that. Although in this case, it does work, but that's specifically because cosine is an even function, and cosine minus theta equals cosine theta. So 2 cosine theta. All right, so I might even just see if I can do that. Let's go back to this page. And I think I might go, I've got most of them here. If I went and take a single snapshot, all right, you can find where that went. Oh, there we go. So I can just pull that up if I need to. All right, so in that case, or at least for the first few anyway. All right, so if I forget them, I'll at least got the first few here. All right, this is going to take a while, so let's go. Okay. All right. Well, it's there. I'll just put it in the background if I need it. Okay. There we go. All right, so let's move on. For H, okay, we got sine pi take theta minus sine minus theta. All right, so just a reminder, because I don't quite always remember these ones. All right, so sine that is actually symmetry, so that's this part is still the part here. It's still sine. It's actually becomes sine theta. Okay, now minus sine theta, you're going to end up with plus, because that minus comes out and cancels the other minus, because sine is an odd function. That's why that works. And cosine, the minus theta, you can change that back into just cosine theta. So we have 2 sine theta over cosine theta. So 2 sine theta over cosine theta will be 2 tan theta. All right. All right, moving on. So making good progress. That was, I just did a bunch of 2F1, and now we got 2F2. 2F2, we're using Pythagorean identity. Let's see how we go. All right, so wasn't too many questions there anyway. All right, simplify. Now, sine 3 sine squared x plus 3 cosine squared x. Now, I can just take out the 3, sine x squared, okay, plus cosine squared x. Okay, that part's going to become 1. So you have 3 times 1 equals 3. Done. All right, let's jump down to L. So I'm doing most of these. I'm just doing the first and the last because there's a lot to do. All right. So cosine, okay, last one. Cosine squared theta minus 1 divided by sine theta. Okay, so we need to kind of reduce, to do that, either convert the sine into cosine or cosine squared into sine squared. That's easy because we've got the identity. That's the kind of the point. Okay, so doing that, cosine squared theta can be expressed as, you can rearrange the thing in such that cosine can be expressed as 1 minus sine squared, so I'll do that. So they replace that with 1 minus sine squared theta minus 1 over sine theta. All right, so question 2, I need to prove this. So start with, now you can't go backwards, you need to go forward. So we're going to start with the Pythagorean identity. Because this comes out of the unit circle, so this was kind of self-explanatory in terms of how you drew it. So remember, like x squared plus y squared equals 1 squared because it's the unit circle. So then what I'm going to do is I'm going to divide top and bottom by sine squared on both sides. So that can be written as sine squared theta plus cosine squared theta over sine squared theta. All right, equals 1 over sine squared theta. So that becomes, okay, now if you reduce that down, you can break this up into 2 separate fractions. Sine squared over sine squared goes to 1. Cosine divided by, so cosine, I might just write as cosine squared. And then this is cosec. So it's 1 over sine squared. And then finally, 1 plus cot squared x, so that's what cosine squared over sine squared would be, equals cosec squared x, and that's your proof. And make sure you've got to start with something and then go to there. All right, so let's have a look. Let's do some more of these ones. Expand if possible. Expand and simplify if possible. 1 plus sine squared theta. Sorry, no, sine theta bracket squared equals 1 plus 2 sine theta plus sine squared theta. I don't know what else to really do about that. Not with the rule we've got so far. Expand and simplify. I suppose I could write it about the squares. Yeah, I guess, oh no. It would be easier if I wrote it. Nah, I think it's fine. That's, I mean, all I could do is replace it with 1 minus cosine squared. I don't think it's going to make it any simpler that way. All right. 3f minus 2. They've only got one trig ratio in these ones. It's probably the ones that have, like, the ones that can be reduced, the ones that have sines and cosines. The ones that examples I'm doing here, a bit more simpler. So keep that minus out there, bracket 2 squared, I should say, minus 4 cosine alpha plus cosine squared alpha. All right, simplifying that. 4 cosine alpha minus 4. All right, sorry for my messed up alphas. All right, moving on. To simplify 1 minus x squared. I shall simplify. I mean, I could write it as the difference of 2 squares, but I'm wondering, can I do something else with it? But just remember sec squared, that is 1 over cosine squared beta. We can write that as 1 2 cosine squared theta beta minus 1 over. So if I wrote 1 as cosine squared over cosine squared, then I can group them together. And then that can be expressed as, okay, cosine beta minus 1 is actually because if I rearrange the identity, so well, basically cosine squared can be written as 1 minus sine squared. So we've got 1 minus sine squared beta minus 1, the ones are gone, divided by cosine squared, equals tan squared beta. I think that's what they desired with that. All right, let's do G. Okay, so we've got sec A minus sine A tan A minus cosine A. All right, so we've got things that are reciprocals. Oopsies, let me move that across. All right, so that's what that you could write that as, because tan is sine over cosine times by sine. You've got sine squared over cosine. That is over cosine. That is not. But if I group them all together, I can write this as 1 minus sine squared A. If I times top and bottom of that by cosine, I can write it as cosine squared over cosine, thereby minus cosine squared A over cosine A. Simplify that. All right, so I have minus sine A minus cosine A. If I take a minus 1 out of that, so minus 1 times sine squared A plus cosine squared A over cosine A. All right. That actually becomes 0 on the top. I think, because it's 1 minus 1 times 1. 0 over cosine A equals 0. That's an interesting relationship. I think, yeah, those functions essentially cancel each other out. By the looks of it. That's interesting. All right, let's keep going. That's 4F2, 4F3 coming up, and I've got more after that. All right, so 4F3. Let's remind ourselves, go back to what's 4F3, what are we doing here? We're just using quadratic techniques to factorize. All right, so let's do that. Alrighty, back to it. All right, so 4F3. Okay, there's some examples there. You can see, okay, you see the examples, difference of two squares. That looks like B. Yeah, it's sum and product factorization. So you think of it, you trig as functions as like x's and y's or a and b's in factorization terms. All right, so 1a. Okay, so something like this, 1 minus, if I'm going to factorize this, it's this it's the difference of two squares, so thereby it is 1 plus sine theta bracket 1 minus sine theta, and that's that. 1f. Okay, so these have both have a 3 and a sine in them. All right, so that was f. That's all I had to do was just take out the common factors. G is actually going to take a bit more work. That's a sum and product type. Been a number of months since I've done one of these. All right, so you consider like your tan theta as your x, and then, okay, well, then what number? So tan plus something and tan plus something else multiplying. Sum of 5, product makes 6. Here I'll cry out, it's 2 and 3. Okay, well, let's do that. It's tan theta plus 2, tan theta plus 3. Okay, expanding out, tan, 3 tan theta, 2 tan theta is 5 tan theta, 3 times 2 is 6. I know I read that backwards, but yeah, 2 times 3 is also 6. All right, so that was simple enough. Yeah, it's just the same stuff as quadratics, just with big functions in them as well. All right, last one looks like a bit more challenging. All right. So you can even just replace, like if you get a bit confused, you can actually just go replace sine x with like a different variable, and then just carry them out like a quadratic, and then just substitute back in. But this one's actually going to have two variables. It looks like you've got sine x, so you'd have to treat sine x as one and cosine x as the other. So in this instance, cosine x squared, I should say. You still can't see the edge of the sheet. All right, need a bit more raising. Now there we go. Cosine squared x. Okay. Let's just make a bit more space for ourselves. All right. So we have the two brackets. We've got number sine x and number cosine x. So it's something sine x plus something cosine x. So sine x plus numeral cosine x, and it's sine x plus cosine x. Now, one of them would have to have for the cosine x would have to have 3. because that 3 can only be multiplied by 1 and 3, because it's a prime number. So I'm going to put a 3 here. All right, but then that means, okay, whatever number, there needs to be a 1 and a 2, but would it be there, or would the 2 also be with the 3? Or would it be here? Let's have a think about that. All right, so if I do 3 times 2 is 6, and then those 2 is 1 more. Yes, so the 2 is there, and these are 1s. Okay, and look, you can essentially think about these, but you think about the expansion. Okay, so 2 sine x times sine x, 2 sine x squared. 2 sine x times 3 cosine x, 2 times 3 is 6. Sine x times cosine x, we have another cosine x plus sine x. So 6 sine x cosine x plus 1 more sine x cosine x will make 7. And then cosine x times 3 cosine x is 3 cosine x squared. Correct. All right, so I thought about the sum and the product, and yeah, that's the factorization. So, all right, so let's simplify some more. All right, using the same sorts of things. So, for example, okay, so we can just reduce these actually pretty easily using things like difference of 2 squares. So 1 sine squared alpha, 1 minus sine alpha. Yeah, and that's how you reduce it. All right. So the next one, I can take the 3 out, but basically it's 1 minus sine squared. Yeah, okay, let's just do it that way. You know what? That's probably better off if we actually used copy that down right. Sine squared. That's better off if I actually went and yeah, I do product. If I factorize that using difference of 2 squares, it'll be 1 plus sine theta over. It's actually better if I use the Pythagorean identity. I'm not sure if that's intentional, but it is actually better that way because that will turn into a cosine. I can reduce it a lot easier. All right, so 1 minus sine theta is actually, sorry, 1 minus sine squared theta is cosine squared theta. It's better to use the Pythagorean identity than any other factorization. Yeah, well, I just said to simplify. So cos the square, that's that. All right, so it's actually 1/3 cosine theta. There you go. Oopsies, using the bare bones on the edge there. Probably should have marked out my working space a bit better. All right, finally, let's do h. That looks a bit convoluted. 1 plus cot theta over cosec minus sec tan plus cot tan theta plus cot theta. Oh boy. Right. Well, maybe I'll just attempt to try to get on the same denominator. This is a bit convoluted. All right, so first of all, cosec, I might as well just bring that up. That's sine theta and 1 plus cot is cosine theta over sine theta. Now if I go minus, I might even see if I bring that down. Cosec is that. All right, cosec I can bring down, so you have 1 over cosec. So sec is cosine on the bottom. And we've got tan, which is tan is sine over cosine. And plus cot is cosine over sine. Theta, close bracket there. All right, so that's a bit convoluted. Okay, bring this in. I can actually cancel there, so that'll be equal to, reducing this, sine theta. I can't see this as a factorization kind of one, but okay, we'll just see what we do. Cancel that. You've actually got plus cosine theta. Maybe it comes up eventually as a problem. This is messy. It's just I'm going to expand this out and see what I get. Minus 1 over bracket cosine expanded into here. That cancels that one, so I'll get sine theta plus, all right, cosine squared theta, if I multiply that into there, over sine theta. If I wrote these two, I can actually reduce that quite nicely. One more line with this, sine theta, oopsies, plus cosine theta, minus 1 divided by bracket. Okay, I write sine as, I want to write this these two fractions together, so I need to have that on the denominator. If I times it by sine over sine, then it can be sine squared theta plus cosine squared theta. There's your identity over sine squared theta. All right. Well, it looks like that's all coming together. I didn't have to do any factorization. Well, not really. There might have been a different path, but I can see what's happening. That becomes 1 on the top there, but it's confusing because it's basically minus 1 divided by 1 over sine theta. That's what's happened there. And then, well, that's minus sine theta, so it's sine theta plus cosine theta minus, because 1 divided by that, you can times by the typical minus sine theta. They're gone, cosine theta. That's the answer. So there might be different approaches to that, but yeah, I got rid of a few things and just moved them around. Expanded, canceled things down. A lot of the cancellation of cosines and sines. All right, so that was for F3. Now actually moving. No, we've actually got. We're still doing 403. We're just doing some question page. Questions on the next page. All right. Show that. Okay, let's do a show that. So the idea you have to start with the left-hand side. I think you can actually start with the right-hand side and show the left-hand side, but that's a bit tricky. So we start with the left-hand side. You can't just grab both sides of the equation and just kind of work together, reduce them. You've got to start with one side, move to the other side. The examiners generally don't tolerate anything else. You can't assume that what you're trying to show is true before you show it. Okay, so we start with the left-hand side. And we try to prove that we get to the right-hand side. Let's just go and expand and see what happens. So that'll be cosine squared theta plus 2 cosine theta plus sine theta plus sine squared theta plus, this is still the same line. Yeah, it's the expansion of the other part. Cosine squared theta minus 2 cosine. See what's happening here. Cosine theta, and then that's plus sine squared theta. Okay, those two parts cancel because they subtract out. And then you've got basically 2 lots of cosine squared theta plus sine squared theta. So 2 lots of 1 equals 2 as desired. All right. E. Sec A minus cosine A equals tan A sine A. All right, well, let's start with the sec A minus cosine A. Start with the left-hand side again. Okay, equals 1 on cosine A plus, minus. And I'm going to write this as a denominator of cosine, so I need a times cosine on top and bottom. So cosine squared A over cosine A, you can group that up now, equals 1 minus cosine squared A over cosine A. And, we can use the identity that becomes sine squared A over cosine A. Now you can write that as sine A times sine A over, just take one of the squares out, one of the sine A's, cosine A, and then we've got what we want. We want tan, or sine over cosine is tan. I'll just switch the sides of that multiplication, which is fine. Yeah. So clears the side. All right. Okay, 3H. And again, a lot of this is, okay, you just start, I'm going to put 3H. I'm going to start here. Sine theta 1 plus cosine theta. All right. Now, what I'm going to do is I'm going to basically, each fraction I'm going to multiply with the top and bottom bar denominator on the other side. So I'm going to go here is, I've kind of done this shorthand so far, but I thought for this one I'll write it out, what I'm doing. And then here would be sine over sine. Okay. That's going to give you, well, this one is going to be on top, sine squared theta plus, now that's going to be 1 plus 2 cosine, well, if I do 2 cosine theta plus cosine squared theta all over sine theta plus sine theta cosine theta. All right. So now I can actually write that out here. I'll expand on, I might as well just work across the page. Oh no, actually, sorry, I'm working down. So I'm going down here. That's actually where I'm meant to be starting it, but I got lots of space. Sine squared, cosine squared. So I've got 1. 1 plus 1 is 2. 2 cosine theta. And the thing about that, I might just take that other part out, sec sine theta. I'll take out the sine theta. So then I have 1 plus cosine theta. And basically, you can see, I'm going to do one more step just to demonstrate this. Take the 2 out as a common factor. 2 times 1 plus cosine theta. And sine on bottom, theta, 1 plus cosine theta. Well, I think we've got it now. Cancel, cancel. It's 2, and sine is CSCX. And that's what we wanted, except it's theta on x. I just changed the variable for some reason. All right. So 3J. Last one of these ones. Okay. Goodo. All right. So same sort of thing. We just want to write this with a common denominator. So So I'm going to times that by, well, basically times by conjugates. So plus sine theta. I'm just going to write out the multiplication that I'm going to be doing to get this common denominator, sine theta, plus 1 over 1 plus sine theta. Okay, so that's what we're looking at so far when we group up the terms. So the multiplication of those denominators with difference of two squares. And then we also have that. Okay, so the sides on the top will cancel, we actually end up with 2. And that can be reduced into now sine squared, so that'll be expressed 1 minus sine squared is actually cosine squared from the Pythagorean identity. Then maybe those other versions of the Pythagorean identity might have been helpful in those other questions. I took too long to do. But never mind. Okay, 2 sec squared theta. That's what we wanted. Okay, so there's all them done. Move on to double angle identities. All right, so double angle identities. Easy to mix those ones up because you've got those different variations of the cosine one. Some have got 1 minus 2, and some have 2 minus 1. So I might have to come back to those in due course, but let's give them a try. Okay. All right, so we're just doing a few of these. So 1b, I think I might have skipped a few more than I've been doing so far, so you get the general idea. Just a couple of them. All right, so using 30 degrees, we're going to substitute and prove. Also, don't forget your unit circle when you're doing this stuff. So now we're substituting. I didn't actually get my unit circle out, but I can go look it up if I need it. All right, for 30 degrees, cosine 2 theta equals cosine squared theta minus cosine sine squared theta. Well, let's substitute in, just check if the left-hand side matches right-hand side. So if I do 2 theta, that'll be 60 degrees equals cosine of 30 degrees squared minus sine of 30 degrees squared. All right. Cosine of 60 degrees is, I believe that's 1/2. Yep. And cosine of 30 is root 3 on 2 squared minus 1/2 squared. All right, so that's 1/2 equals 3 on 4 minus 1 on 4 is 2 on 4, which is also 1/2. So tick, that's the same. Left-hand side. Yep, left-hand side equals right-hand side. If sine, okay. So if you know the ratios, find the exact values of those. Okay, we can do that. Tan of, I just jump with tan of 2 theta. We just go to the double angle formula for that, and that is equal to 2 tan theta, 1 minus tan squared theta. Okay, so worth the while to just, okay, we'll just go and substitute those in, but first we've got to figure out what, well, tan theta is equal to sine divided by cosine, 4 over 5 divided by All right. So just let's just go and simplify that. So we've got 2 times 3 on 4 on 3, so that's 8 on 3, and we're dividing by 1 minus 16 on 9. That's 9 on 9. All right, so 9 times, I'm going to, so 9 on 9, sorry, 9 takes 16 on 9 is going to be negative 7 on 9, which would be minus 9 on 7, 3, something to that effect, minus 24 on 7, oops, 24 on 27. All right, something like that. Okay. And let's just do another one. Okay, why not? So cosine A equals that. All right, cosine A equals 1/3. So cosine 2A equals, now we'll use the one that for cosine. So cosine 2 theta is 2 cosine squared A minus 1 equals 2 times 1/3 squared minus 1 equals 2/9 minus 1 equals minus 7 on 9. So this one 4b, so I'm working out that. If sine x, y, actually kind of have to work out to do 4b, I have to do 4a. Yeah, because sine double angle actually requires both. Okay, let's just do both. So sine equals minus sine alpha. Okay. Sine squared alpha equals 4/9. 1 minus cosine squared alpha equals 4 on 9. Okay, switching that across. That could be 9 on 9. Cosine, if I switch those around, cosine squared is 5 on 9. And then this is in the third quadrant, so that's actually negative. So cosine alpha equals minus root 5 on 3. And then sine 2 alpha equals, was it cosine minus sine or sine minus cosine squared, of course. Nope. It's not the ones I'm thinking of. No, that's one of the cosine. It's 2 sine theta cosine theta. All right. Yep, well, we got those. So 2 cosine theta or alpha sine alpha equals minus 2 thirds times minus root 5 on 3 equals 2 root 5 over 9 positive. All right, moving on. So, question 6. If it's okay, if alpha is acute, you got that. All right. All right, so this is using the cosine double angle formula to work out cosine and sine. So I'll just do the first one. All right, so cosine 2 alpha, let's go back to the cosine one, equals minus 7 on 9. And this is acute, so it's in the first quadrant. That's his. I can't actually, 2 theta, I should say. Okay. And then so we got that one, that's the one. So that's equal to okay. All right, so cosine squared theta divided by 2 is 1/9. Equals 1/3. It's if it's acute, it'll be, yeah, it's in the first quadrant, so positive. All right, so that's that one. All right, back to questions. All right, 7b. Find the exact value of tan A. All right, tan 2A. All right. Okay, give that a try. So tan double angle formula, as you got it written up above there. Okay, that can be written as yeah, I have to write this whole thing out. 2 tan A over 1 minus tan squared A equals minus 12/5. All right, well, what do you do with that? You're going to expand. I'm going to multiply that part across and times by 5. So I'm basically going to multiply 5 bracket 1 minus tan squared A to both sides. That's going to affect cancelling that, and that will cancel out, and you end up with 10 tan A equals minus 12, 1 minus tan A squared. All right, that's A, tan squared A. All right, so if we bring that across, 12 then basically we're going to go factorize this. That's a pain. What if I made a mistake there somewhere? 12 times by 5, 10. Yeah, I think that's. I'm going to make myself a bit more space. Get rid of that. I need it. I'm going to need it. Okay. Alrighty. So there's a few ways I could actually factorize that, but I think it's 10. I'm assuming I can factorize that all right. All right, so number 10a plus equals 0. Tan a plus something. All right. So trying to think what these are. Okay, so those have to multiply to make 6. So that could be 2 and 3 or 1 and 6. That's unfortunate. If it was 1 and 6, no, it can't be that. It'd have to be 2 and 3, and these both have to be. I don't think that's actually going to work. I'm not entirely sure what I've done wrong there. A quick little peek at. Let's have a quick look at that again. It was 12 on 5, and that's cute. All right, so I don't waste so much time. Let's have a quick. Don't like to do this often, but instead of wasting time on a very long video, have a quick look at. Have I done something wrong? That doesn't always going to factorize. So we're going to do. What are we up to? Trig functions. To page 234. No, we're up to G. All right, and we got H after this. G, and we're doing This was question 7b. That's correct. Oh, I forgot the negative. That's why. No, that looks about right. Oh no, if I bring that across, that's yeah, there's a problem with the signs in here. All right. So then that's yeah, that's negative. And then so is that. That'll be positive. If I brought that across, it'd be negative, and that's negative, and that becomes positive. Yes, that's the problem. Let's cross those off. All right. So then, okay, then you can group these up. I might still take out the 2. Tan, well, 6 tan squared A minus 5 tan A minus 6 equals 0. All right, and I mean, okay, well, look, we got it in front of us, so let's just finish this off. 3, the factorization now actually works. Tan A, because I got the negatives correct. 2 and 2 tan A minus 3 equals 0. That's the factorization. I can discard the 2, just divide it out. And I've got, use Null theorem rule, I've got 2 tan A plus 2 equals 0. That ends up with tan A equals minus 2 on 3. Now that one I believe we discard because it's not acute. Because tan is positive in the first quadrant. And then the other one should be a run. Tan A equals, well, 2 tan A minus 3 equals 0. And then that one will end up being tan equals 3 on 2. And that one is fine. All right. So what's the other ones I was planning on doing? Cross out 10b. Let's do question 8. Now that's an interesting one. Well, that's a Trigonometric we don't know, but can we express that as a fraction in terms of something? Okay. All right. Can we work that out? Something that we do know, like tan. So we haven't got the half angle formulas. No, was that introduced? Tan of 1 on 8. We haven't done the addition formula. So tan of 1/8. That's our pi on 8. If we know how to do tan of pi on 6, pi on 3, and pi on 4, what about tan pi on 8? How would you do that? Well, because if we actually treat that as a double, then we disband into that one. There's actually this half angle formulas where they're kind of the reverse of these, but I don't know how they haven't been introduced. A quick squiz on that, expecting us to do for that. Oh, I suppose that's how we can go back and think of it. That looked right to me, actually. Oh, yeah, because, okay, fair enough. So tan, we know what tan of this is. Okay, tan, no, I suppose we would have to go through something like this, unfortunately. 2 times pi on 8 is one that we know, which is pi on 4. Tan of pi on 4 is 1. All right, now if we use a double angle formula, we can actually go and work out. So let's go substitute that in. All right, back to our tan double angle formula. Yeah, 2 times pi on 8 is pi on 4, which we know is 1. But now we can use the double angle formula to go and express this in terms of pi on 8. Tan of, or 2 tan pi on 8 equals 1. 2 tan pi on 8 equals 1 minus tan squared pi on 8. We got that. Okay, so now let's go and see if we can factorize that. Tan pi on 8 okay, whoopsies. Tan pi on 8 and tan pi on 8. Sum and product, so sum equals minus 1. Or, sorry, sum equals 2 actually. Product is minus 1. Minus 2 and 1, no. Doesn't make any sense actually. Again, if I stuff this up. Oh boy. Have I done something wrong with the signs? No, not in this case. Or have I? No, that's actually positive. Brought everything across to that side. I think I've stuffed this up. I'm making a lot of errors tonight, so I'm just going to have a quick squiz, see what I've done wrong. Oh boy. Oh no, this one actually needs you can't factorize it. Quadratic equation. Fair enough, I suppose. It actually makes sense. Yeah, okay, so let's go from this. So yeah, you can treat this like it's quadratic equation. So x squared plus 2x minus 1 equals 0. Yeah, can't factorize that. It was actually correct. Minus b minus 2 plus or minus 4 squared minus minus 4ab for AC, I should say, over 2a. So that's actually minus 2 plus or minus 4a, no, minus 1. So that actually becomes root 8. Which can be reduced to minus, okay, that's minus 1 plus or minus 2 root 8 can be written as 2 root 2. Divided by 2 is root 2. Now, so let's bring it back. That's x, but it's also tan pi on 8. And the first, yeah, where we're going to take the first one being the fact that it's acute, so then it's positive in the first quadrant. So thereby, all right, so it's minus 1 plus root 2. Or 2 minus root minus 1 for the fair. I was going to do 10b. Yeah, 10. There we go. Fine. I think I had a blank page over here. I still got some space I haven't used yet. 10b. It's another one I was going to do. Use appropriate double angle identities simplify. Okay. So just match this up. I'm going to take the 2 out, match this up with one of the known double angle formulas, and then it's basically 2 sine 2 alpha. Easy. Okay, now let's have a look what else I plan to do. All right, over the page. 10. No, actually, no, same page. 10G and 10Q. G, all right. 2 sine squared m minus 1. Let me just double check. That is related to one of the cosine double angle formulas. Is it exactly? No, it's the negative of it. So if you notice here, the one that has the sine squared, that's 1 minus. So if I reverse that, minus 1 minus sine 2 sine root m equals minus cosine 2m, like that. Let's go with Q, 10Q. All right, sine cosine minus cosine squared minus sine squared. Back to, that's what I want. Double angle. It's yes, it is cosine minus sine. So then I can just that this goes to cosine. That's cosine 2 lots of the angle. All right, so that's interesting. We've actually got something that has that's going from half to back to cosine alpha. So there's your half angle formulas are starting to show up, or at least a variation thereof. Okay. Moving on, 11b. Show that. Okay. Well. All right, cosine of, oh, it's right up here. So I've got my space. Cosine 4 theta minus sine 4 theta. Now you can write those as the difference of 2 squares. When I say that, like this, I mean they are the difference of 2 squares in that respect. So you can square them like that, and then you can write, okay, well that's equal to cosine squared plus sine squared theta, and cosine squared theta plus minus, sorry. What have I done? Sine, that was the problem. Minus sine squared theta. That just becomes 1. Was this meant to be? No, it is the same thing. Cosine squared minus sine squared theta, just 1 times that, and that's actually the double angle for sine. So it is sine 2 theta. So like powers higher, I imagine, like at least if you keep going up powers of 2, I think that might be a common pattern. You just end up back at the double angle. All right, so we've shown that. 12c, let's just do it here. 12c. Solve exactly. Okay. Sine 2x plus 3 sine x equals 0. I can write that. There's only one double angle formula for sine, so that's 2 sine x cosine x plus 3 sine x equals 0. All right, and let's just factorize that and see what we can do with it. Sine x 2 cosine x plus 3, I think. Equals 0. So I think that's I might double check this one as well with the word solutions. We've got cosine x equals 0, and you can find solutions for that from 0, 0, pi, and 2 pi. And the other part, cosine x, 2 cosine x plus 3, this can't work. Minus 3 on 2, and that's not possible. Unless I made a mistake. I'm just going to double check because I've made a few tonight. And good thing I got this with me. Okay, so let's have a look. 12c. Yeah, that's not possible. Cosine can't be defined for anything less than minus 1, so minus 1.5 is not possible. Yeah, so we got the 3 solutions here. So, okay, I'm going to trust myself eventually. Let's not making so many mistakes. All right, use a double angle identity to show that. Okay. So I'm going to do 13a, A part 2 and B part 2. All right. So starting with the cosine double angle identity, the one that goes into the other cosine. Let's just see that one again. Okay. All right, that's 2 cosine squared theta minus 1. Now, unfortunately, I've gone and used. No, it's fine. All I've got to do is all right. Rearrange this. All right, so add 1 to both sides. And divide by 2. So cosine squared theta can be expressed as 1 plus cosine, 1 half plus 1 half cosine 2 theta. Then if you let x on 2 equal theta, you can actually demonstrate there's a relationship where you can actually halve things. I think that's what we're getting at the second one. Cosine x on 2 equals half plus a half cosine of 2x on 2, which would just be cosine x. So basically, I mean, they might actually go through and in their method, they might show the full derivation all over again. I'm not sure. But it is kind of the same principle. Substituting, yeah, I don't like the idea of substituting variable for variable, so I use x instead of that. But that's exactly what they've gone and done. All right. So that was actually that part there. Okay. Moving on. 14b. All right. Find the exact value of cosine A in the diagram. All right. Okay, so it looks like we got some opposite pairs here, and that might be good to use the sine A over sine A over 2 centimeters equals sine 2A equal over 3. Okay, so that's the sine rule I just used there. All right, now using the double angle formula, 2 equals 2 sine A cosine A on 3 times by 3 times by 2. 3 sine A equals 4 sine A cosine A. All right. Then 4 sine A cosine A minus 3 sine A equals 0. All right, so you got that. So, I mean, we've got solutions for that. So the possible solution, you have sine a equals 0, and you've got all those solutions. That's kind of trivial because that's basically when top and bottom equals 0, so thereby the triangle collapses. So it's kind of trivial. And then you've got 4 cosine a minus 3 equals 0. Cosine a equals 3 on 4. That makes sense, and it's also acute. So, yep, that looks right to me. Oh, me doing this actually late at night. Okay, so prove that. Okay, let's do that one. Okay, so I don't think of the best one. Okay, let's just write it down first. Sine 2 theta, right at the left hand side, minus. Okay, I know what to do with the top. 2 sine theta, cosine theta. Now I'm going to look for one that cancels the one there for minusing 2 theta. If I do, okay, if I do the second one, that will cancel the other one. So then basically it's 1 minus bracket 1 minus 2 sine squared theta. Okay, so you end up reducing it to that. And then we can cancel one of the signs on the top and one on the bottom. And as we cancel the 2's, you end up with cosine theta over sine theta, and that's cot, which is what we wanted. All right. There we go. Yes, what we wanted. And I said 15e. That might be interesting. It's a bit of space. All right. All right, so let's see what happens with this one. I kind of get the first part. I might even just leave this second part alone for the time being. So 2 sine theta cosine theta over sine theta minus cosine 2 theta. Cosine theta. Okay, we can cancel those, and I get 2 cosine theta minus cosine 2 theta over cosine theta. All right, now let's go and I'm going to even take this down here. All right, next line, I'm going to actually use the double angle formula that makes another cosine, and I'll reduce those because I think that's where this is going. I'll show you what I mean. 2 cosine theta. Okay, minus cosine. Okay. One minus cosine. I've written that backwards. Sorry, I've written the wrong one. Cosine squared theta minus 1 on cosine theta. Okay, equals 2 cosine theta. Now, if you break this up, you can write this as minus cosine squared theta over cosine theta. Minus 1 over cosine theta. All right. So you actually answer 1 cosine theta minus 1 over cosine theta. What did I actually need at the end of the day? Because then that's one of those was reduced. I need to get sec theta. It doesn't look like it's going to be. I got sec theta here. I thought that would cancel. Did I do something wrong with the numbers? I did. I've done the wrong substitution again. I need a 2. Then that's a 2. And then that's cancelled. And then it's sec. And that's positive as well. That's minus minus. I keep doing that with my negatives. Oh boy. Okay. All right. I think that's the okay. Now up to the last part. So we're now up to H. Angle and sum difference. And you notice that I've actually cut that off here. But actually, I can see what I've done. Sine, cosine, cosine, sine. But you can see enough that I'll be able to do it anyway with what I've just taken the photo of here. All right, so move on. All right, simplify. 1c cosine alpha cosine beta. Actually, well, we've got them right in front of us, so we can just go back to this page, I suppose. We can look at them here. Cosine, okay. Beta minus alpha minus sine alpha sine beta minus alpha. All right, so we can actually use the reverse of one of these. In fact, we use the second one. Treat beta minus alpha as b. So we've got a minus here, so there's a minus there, that have to be a plus. So we're going to, then that's a cosine. We're going to add those, whoops, cosine of alpha plus beta minus alpha. So we actually kind of did this from right to left. All right, and then simplify that is simply just cosine beta. Okay. 2a. See if we can squeeze it into there. Simplify, okay, tan. Yeah, actually, I didn't actually write, well, I did have tan on my nose, but I didn't catch it in the photo. All right, that's all right. Look at it on this page. Tan, okay, that's tan a minus pi on 4. Okay. That's going to be a bit of work. All right. So basically, we have to expand. It's not a factor. It's not. We're not going from right to left. We're going from left to right twice. So think of it this way. Okay. So a. So the first part here, got tan a plus tan pi on 4, and then we have 1 minus tan a tan pi on 4 times tan a minus tan pi on 4 over, this would be 1 plus tan a tan pi on 4. Now every pi on 4 and every tan pi on 4 is 1. So let's reduce that down. I'm going to write it over here. Tan a plus 1 and 1 minus tan a and then that's tan a minus 1 Okay, I can see straight away that's okay, top and here. This one's just the negative of that, so if I wrote it out, I can write -1 minus tan. Oopsies, had that backwards. One more time. Okay, those two parts are cancelled. So equals -1, 1 minus tan A divided by 1 minus tan A. So there's a cancel. Then the answer is -1. Okay, a bit messy. There we go. -1. Okay, question 4. Alrighty. To do this again. Should pick better questions. All right, look, I picked it, so I'm going to do it. All right. Again, it's another one of mine. It's like big multiplication. Always no better way. I think there might actually be. No, there's not. Because I'm not going to jump into sines and cosines. Might as well just do it with the tans. All right, let's just do it. Okay, I'm just going to go straight for the expansion. Tan A minus tan B over 1 plus tan A tan B times all right. I is meant to be find tan. Okay, that's equal to 1. So if I multiply that across there, I could actually go and expand these. Tan A minus tan B bracket and tan A plus tan B, and then multiply these across. 1 plus tan A tan B, 1 minus tan A tan B. This is messy. That's the difference of 2 squares. So tan A squared minus tan B squared, and this part 1 minus 2 tan A tan B minus tan squared A tan squared B. Okay. That's a mess. Is that really the way what we have to do? Oh boy. I'm going to check this one and see if I'm actually not got off the wrong tangent. 2, 4. Oh yes, that part would actually count. No, that doesn't double up. That part's gone. My bad. Because that's a difference of 2 squares as well. So that's not there. Yeah, that's just negative. That part is not part of it. Yeah, so All right. So let's group up. Let's get everything that has a tan A in it. Bring that across here. Tan squared A plus tan squared A tan squared B equals 1 plus tan squared B. I'm going to bring everything across one side. No, let's have a look at that again. Let's finish it off. It's getting a bit tricky. Yeah, they took out, so yeah, that's what they did. Oh yeah, it actually cancels out nicely. Okay. Tan squared A 1 plus tan squared B equals 1 plus tan squared B. We divide that across, they're the same. Tan A equals 1, and then tan squared. So tan squared A equals 1, and then tan equals plus or minus 1. Yep, that's the side. Okay, that was a bit messy. So let's try some other ones. I said I'd do 6C. All right. 6C. Start with the left-hand side. Cosine alpha plus beta. Cosine alpha minus beta. And let's go for that expansion. What can we do? What can we do? All right. Cosine alpha, cosine beta. So cosine alpha, okay. So plus and then be minus sine alpha sine beta. And then the second one is plus cosine alpha cosine beta plus sine alpha sine beta. Oopsies, can't see it at all. There you go. All right, and those cancel. So it's 2 cosine alpha cosine beta. Was that all I had to do? Show that. No, I had to get the squares. Oh no, hang on. They're not adding. They're multiplying. That's silly. All right. Well, I can see that working as basically the difference of two squares. So yeah, it's cosine alpha squared cosine beta squared beta minus sine alpha sine squared beta. That's not what we want either. We want cosine alpha. Let's check if I've done this right. So it's okay, so alpha plus beta, so cosine alpha sine. Yeah, it's cosine cosine sine sine, and that's minus if that's plus. And then it's cosine cosine plus sine sine if that's negative. That's correct. I didn't expand it, and it's the difference of two squares. Then what we do? I imagine we're just going to use so you're going to use Pythagorean identity to get the desired format. So this is 6C. So we want a cosine squared alpha. So let's just change that couple more lines. Cosine squared alpha, and then I can just change that into a sine, 1 minus sine squared beta. And we want a sine, we want everything in terms of sine beta, not sine alpha. So that's going to be, I'm going to change that into minus 1 minus cosine squared alpha sine squared beta. All right, expand and simplify. Cosine squared alpha minus cosine squared alpha sine squared beta minus sine squared beta. Yep, and those two will cancel, that's easy. And then we got what we want. There we go. All right, then we got a few more to do. I said I'll do question 7. Let's do that one. Question 7. Oh boy. Prove the figure alpha plus beta equals that. Well, just looking at those, just in terms of ratios. So if you think about tan, so tan alpha equals, well, if you look at that, you've got, remember tan is opposite of adjacent, so tan is that, that's 1/3. Because you've got 1, 2, 3 in the bottom and 1 up. Tan beta equals 1 rise over 2. And let's consider, okay, well, let's go with addition form. Tan alpha plus beta equals, so go with, all right, should be able to see that. All right, so let's go back up here. Equals tan A plus tan B over 1 minus tan A tan B, and let's substitute those in because we know what those are. Well, they're out, sorry, I should say alpha and beta. Alpha and beta. Okay. All right, tan alpha, so we've got 1/3 plus 1/2 minus 1 minus 1/3 times 1/2. So bring that fraction down here. 1/3 plus 1/2 can be 2/6 plus 3/6 is 5/6 divided by what was on the bottom. So that's 1 minus 1/6. So that will be divided by 5/6. And that's equal to 1. So then tan alpha plus beta equals 1. And that's well, that requires alpha plus beta must equal pi on 4 to achieve that because of cubed. And that's what we wanted. Okay. All right. Yes. And here's the last questions, as you said. So I think I've been working for a while. This is going to be one of the longest videos I've done. Nearly gone for 2 hours. So I don't expect anyone to watch this in entirety. I'm tired. Okay, let's go. All right, so let's prove. So we've got a triple angle. Well, we know 3 is more than 2. 1 more theta, so we can either write this out as theta plus theta plus theta, but maybe I'll just try this, see if that works. So we've already worked with double angle formulas. So let's use our addition formula for sine. Let's see what happens. Sine 2 theta cosine theta plus cosine 2 theta sine theta. Okay. So, all right. 2 sine theta cosine theta cosine theta. I'm not sure what to want to use here. Now let's go back to what we want at the end of the day. Okay. Sine, we want to write in terms of sine 3 theta. Okay. Then use the double angle formula for cosine that makes us sine, which should be 1 minus 2 sine squared theta. All right, so cosine squared, I'm going to turn that into sine by doing 1 minus sine squared theta plus. Okay, sine, because I want to change everything to sine. That seems to be what I want. All right. And over here as well, 2 sine theta minus 2 sine cubed theta plus sine theta. Yeah. All right, so that's, I believe that's the format they want. Well, maybe just switch the sides. Yeah. Well, yeah, thereabouts. It's minus 4 sine cubed theta plus 3 sine theta. That's it. All right, hence solve the equation. All right, so, well, that's equal to, okay. Well, 3 theta, the part B, sine 3 theta equals sine theta. You can replace it with sine theta minus 4 sine cubed theta equals sine theta. It's cubed, looks more like a 3, yeah. We'll bring it together, it'll look all right when I've done it. All right, so 4 sine cubed theta, bring that across that side, minus 2 sine theta. So that's gone across that side, and then I'll equal that to 0. Take out a common factor of sine 2 sine theta, and then I've got 2 sine squared theta minus 1 equals 0. All right. So, and then got difference of 2 squares. So I might as well just go and write this all out. Okay, in terms of factors. Okay. Yeah, let's do it that way. Okay, well, it's actually going to be root 2 sine theta plus 1 and root 2 sine theta minus 1 equals 0. So I've got sine theta equals 0. That's this one. I'll have sine theta equals, bring that across, minus 1 on root 2. And I have sine theta equals positive 1 on root 2. Okay, so then I have to write out all the solutions for those from 0 to 3 pi. Fun. Okay, well, let's just do that one. That one I know top of my head. 0 pi, 2 pi, and 3 pi. Sine theta equals, well, those are, okay, that occurs, that's the 45-degree ones in the third and fourth quadrant. So that's, well, this is the positive one, so I might need to do this one first. All right, so that's pi on 2 and pi on 3 pi on 2. That's the first and second quadrants, and then third and fourth are negative, and then you have one more. So 2 pi plus that. So the next one is well, yeah, pi on 2 more than that. Sorry, 2 pi plus pi on 2 is 5 pi on 2. Yes. Hang on, what am I saying? Pi on 2. I mean pi on 4. And then 3 pi on 4. My bad. And that was incorrect. So then that's 2 pi is 8 pi on 4, and that's 9 pi on 4. My bad. Is the next one, and then everything else falls outside the domain of 3 pi. No, it doesn't. I think I've got one more. So that's 11 pi. Okay. And then 12 pi and 4 is 3 pi. So it's actually there's first quadrant, second quadrant, nothing in third and fourth, and then you go around the next circle. So you can call that the fifth and the sixth quadrant. And then the sixth quadrant ends at 3 pi. Now, nothing in first and second. We would have 5 pi on 4. And there's 7 pi on 4. And that's it. Because so you go around the second circle, but you only go up to 3 pi. So that's the solutions. So in total, these are all your solutions. And you can write them out in order if you want to, but I'm going to leave it there. Okay, so, yep. Yeah, just practice makes perfect, I suppose. And yeah, with enough practice, this should become pretty routine, but all the same, so don't be surprised if